A fuel cell is a device that converts the chemical energy from a fuel into electricity through a chemical reaction of positively charged hydrogen ions with oxygen or another oxidizing agent. Fuel cells are different from batteries in that they require a continuous source of fuel and oxygen or air to sustain the chemical reaction, whereas in a battery the chemicals present in the battery react with each other to generate an electromotive force. Fuel cells can produce electricity continuously for as long as these inputs are supplied. The first fuel cells were invented in 1838. The first commercial use of fuel cells came more than a century later in NASA space programs to generate power for satellites and space capsules. Since then, fuel cells have been used in many other applications. Fuel cells are used for primary and backup power for commercial, industrial and residential buildings and in remote or inaccessible areas. They are also used to power fuel cell vehicles, including forklifts, automobiles, buses, boats, motorcycles and submarines. There are many types of fuel cells, but they all consist of an anode, a cathode, and an electrolyte that allows positively charged hydrogen ions to move between the two sides of the fuel cell. The anode and cathode contain catalysts that cause the fuel to undergo oxidation reactions that generate positively charged hydrogen ions and electrons. The hydrogen ions are drawn through the electrolyte after the reaction. At the same time, electrons are drawn from the anode to the cathode through an external circuit, producing direct current electricity. At the cathode, hydrogen ions, electrons, and oxygen react to form water, as the main difference among fuel cell types is the electrolyte. Fuel cells are classified by the type of electrolyte they use and by the difference in startup time ranging from 1 second for proton exchange membrane fuel cells to 10 minutes for solid oxide fuel cells. Individual fuel cells produce relatively small electrical potentials, about 0.7 volts, so cells are stacked, or placed in series, to create sufficient voltage to meet an application's requirements. In addition to electricity, fuel cells produce water, heat and, depending on the fuel source, very small amounts of nitrogen dioxide and other emissions. The energy efficiency of a fuel cell is generally between 40 to 60%, or up to 85% efficient in cogeneration if waste heat is captured for use. The fuel cell market is growing, and Pike Research has estimated that the stationary fuel cell market will reach 50 gigawatts by 2020. History. The first references to hydrogen fuel cells appeared in 1838. In a letter dated October 1838 but published in the December 1838 edition of the London and Edinburgh Philosophical Magazine and Journal of Science, Welsh physicist and barrister William Grove wrote about the development of his first crude fuel cells. He used a combination of sheet iron, copper and porcelain plates, and the solution of sulfate of copper and dilute acid. In a letter to the same publication written in December 1838 but published in June 1839, German physicist Christian Friedrich Schobein discussed the first crude fuel cell that he had invented. His letter discussed current generated from hydrogen and oxygen dissolved in water. Grove later sketched his design, in 1842, in the same journal. The fuel cell he made used similar materials to today's phosphoric acid fuel cell. 9. In 1939, British engineer Francis Thomas Bacon successfully developed a 5 kilowatt stationary fuel cell. In 1955, Thomas Grab, a chemist working for the General Electric Company, further modified the original fuel cell design by using a sulfonated polystyrene ion exchange membrane as the electrolyte. 3 years later, another GE chemist, Leonard Niedrich, devised a way of depositing platinum onto the membrane, which served as catalyst for the necessary hydrogen oxidation and oxygen reduction reactions. This became known as the Grubb-Niedrich fuel cell. GE went on to develop this technology with NASA and McDonnell Aircraft, leading to its use during Project Gemini. This was the first commercial use of a fuel cell. In 1959, a team led by Harry Irag built a 15 kilowatts fuel cell tractor for Alice Chalmers, which was demonstrated across the U.S. at state fairs. This system used potassium hydroxide as the electrolyte and compressed hydrogen and oxygen as the reactants. Later in 1959, Bacon and his colleagues demonstrated a practical 5-kilowatt unit capable of powering a welding machine. In the 1960s, Pratt & Whitney licensed Bacon's U.S. patents for use in the U.S. space program to supply electricity and drinking water. In 1991, the first hydrogen fuel cell automobile was developed by Roger Billings. UTC Power was the first company to manufacture and commercialize a large, stationary fuel cell system for use as a cogeneration power plant in hospitals, universities and large office buildings. In recognition of the fuel cell industry and America's role in fuel cell development, the U.S. Senate recognized October 8, 2015 as National Hydrogen and Fuel Cell Day, passing S. Res. 217. The date was chosen in recognition of the atomic weight of hydrogen.